Good day, everybody. My talk today is on conservation and management of mangroves and salt marshes, looking back to move forward. And I thank the Australian Mangrove Saltmarsh Network for this invitation. So my research group focus is on blue carbon ecosystems and responses to climate change, looking at saltmarsh and mangroves, but also seagrasses. We look at the conservation and management of estuaries, including environmental flow requirements, ecological health and importance indices. We also look at water quality issues, eutrophication and harmful algal blooms, although I won't speak about those today. And the research is multidisciplinary and multi-institutional. We work with the Water Research Commission as a funder, with the CSIR, Stellenbosch University, the NRF, Anchor Environmental Consultants, and it has been like this for the last 25 years. So I will report on some of the experiences of working in these teams. I would also like to acknowledge the inputs of my past and present postgraduate students, having graduated 35 MSc and 22 PhD students over the last number of years. Our research bridges the science policy practice divide. We implement the knowledge to action cycle. And we have provided input on the National Water Act, the Integrated Coastal Management Act, international agreements such as the Ramsar Convention and the Biodiversity Convention. So we make sure that our research is applicable and used by a variety of stakeholders. In the talk today, I will talk about the characteristics of South Africa's estuaries, then some specifics on mangroves and saltmarsh, how we have linked science policy and management, and then move on to restoration and the need for a socio-ecological systems approach for restoration, and at the end give some personal reflections on the topic of looking back to move forward. So in South Africa, we have a very high energy coastline. And for this reason, our saltmarsh and mangrove habitats are situated in the sheltered estuaries. There are 290 estuaries along the 3,000 kilometre coastline. And they are microtidal, they occur on a wave-dominated coast. The estuaries are highly dynamic and shallow of about 2 to 3 metres. They're small, with about 70% of them less than 50 hectares. They're characterized by strong wave action and high sediment availability. And because of this, more than 90% of our estuaries have a restricted mouth, a restricted connectivity with the sea. In fact, 75% of them close for varying periods when a sandbar forms across the mouth. The mean annual runoff for the freshwater inflow is also very variable, fluctuation between floods and low to zero flow. And our systems are laterally confined. They're located in bedrock valleys with only very few coastal plain estuaries up on the northern east coast. So we have 9 estuary types in 4 biogeographic regions, and we classify these types as lakes, bays, lagoons, systems that are permanently open to the sea, and those that are temporarily closed, fluvially dominated systems that are characterized by a large freshwater inflow, and arid, predominantly closed systems. These range from the west coast, where we have a rainfall gradient along our coastline from the west to the south to the east coast of less than 100 millimeters to over 1,000 millimeters on the east coast. And so we have 4 distinct biogeographic zones ranging from cool temperate to warm temperate to subtropical. And because of this rainfall gradient, we have a seasonal opening in estuaries to the sea. So on the west coast, where it is a winter rainfall region, they will open up and be connected to the sea in winter. There'll be unpredictable opening along the southern Cape coast and summer opening along the subtropical coast. This, of course, influences the mangrove and saltmarsh habitats. And part of what I will report on today is our long-term monitoring data and observations that have allowed us to make future predictions about climate change, or future predictions of these habitats in response to changes in freshwater inflow as a result of abstraction. There is an understanding nationally that healthy systems provide the ecosystem services that we are dependent on, ranging from nursery areas, aesthetic qualities, food to flood control. Healthy mangroves and salt marshes provide these numerous ecosystem services. Culturally, some of the systems are very important for sangomas and traditional healers. And then we have to be very careful about the water quality in these systems. And the mangrove and salt marsh habitats play an important role in maintaining this water quality. However, in South Africa, as it is globally, these habitats are threatened by development, agriculture, changes in freshwater inflow, and deterioration in water quality. Also, lack of governance, implementation of legislation, and coordination across government departments is sometimes weak. But our research on these topics has contributed to policy development and implementation of national legislation in the country. As I said, if we first look at our mangrove habitats, they are found along the subtropical coast. Well, in fact, they extend from the warm temperate to the subtropical to the tropical habitats. Our research has assessed mangrove cover, loss of habitat, and management responses. We have a very small area of mangroves, basically 1,600, 1,700 hectares, but they're recognized as being vitally important for biodiversity conservation. They are, however, very dynamic environments occurring in small estuaries. They're exposed to extreme events such as floods and droughts. And globally, they are of interest because they're at one of the most southerly limits, and we study the global change responses. So we've used our historical data to track changes over time, and in some cases we have 20-year records of what mangroves are doing in specific estuaries. It's also very important for us to quantify what has been lost so this can guide future restoration initiatives. This figure shows the distribution of mangroves along the east coast, and it shows those estuaries where there has been losses in cover and those where there's been gains in covers. So interestingly, a large area of mangrove was lost when the Durban Bay harbour was developed. But on the other hand, we had a large gain in mangrove area when the Richards Bay harbour was developed, because here an artificial mouth was made to the sea, the Umshutuzi became a nature reserve area, and the now large available intertidal habitat led to rapid mangrove expansion. So in South Africa, we now have the largest mangrove area occurring in one of our modified systems. We have case studies to show on the southerly limit on our east coast, for example at Nahoon Estuary, mangroves were planted here, and they've showed a rapid increase in area and expansion over the available intertidal habitat. Our coastline serves as an outdoor laboratory where we can test the expansion of cool temperate taxa. We see the expansion of subtropical taxa along the east coast, and we're actually finding a squeeze on warm temperate taxa. So we're understanding these responses to climate change, and we're doing range expansion, monitoring and research. We have case studies to show recent climate change effects or impacts, such as a reduction in freshwater inflow due to abstraction, but also because of drought. At this particular estuary, the mouth closed to the sea, the water level increased, and the mangrove roots or the pneumatophores were flooded. There was rapid dieback of the mangroves, and as the bottom figure shows, there was replacement of a mangrove by saltmarsh. And now, a number of years later, 6 years later, we still have saltmarsh being the dominant habitat type in that system. In other estuaries, we see the effect of sea storms that are increasing in intensity because of climate change. At the Mbashi estuary here, there's been sediment deposition from sea storm and dieback of mangroves in response to that. In some of the smaller estuaries where mangrove area is 6 to 3 hectares, they're very dynamic, and sometimes we would go and sample there and there would be no habitat available. So they come and go in response to freshwater floods. With climate change, we do know that our estuaries will become less stable, influencing mangrove propagule dispersal, seedling establishment and survival. Not only are we trying to predict climate change effects on mangrove habitats, but we also try and understand anthropogenic pressures. And we have some very unique pressures along our rural Eastern Cape coast, where we find a very low adult to seedling ratio of mangroves. No seedlings or saplings were observed in 35% of the estuaries along that coast. And the culprits were goats feeding on propagules and reducing recruitment, or cattle browsing also causes sediment compaction, but browsing on the trees leads to loss of above ground material. These are free-roaming cattle, so very hard to control that sort of pressure. Another pressure is harvesting of mangrove trees. But we actually find that in some of these rural areas now people are using bricks and other things to build their houses and animal shelters. This pressure is reducing over time. So if we look forward now, what should we be doing about mangrove conservation in South Africa? We find when we look at protection status that our northern systems that do have very large areas, they are protected. For example, stretching from Cozy Bay to St. Lucia, we have the Isimangaliso World Heritage Site, and these mangroves are protected. But as we move down the coastline, fewer of those habitats occur in protected areas. And if we identify some of those systems for future conservation or protected area expansion, it would be Umgazana Estuary, which is the most southerly limit for the red mangrove, Rhizophyra mucronata. Or it would be in the natural limit at the Wavecrest Estuary, which is the historical limit for mangrove distribution along the east coast. So our ongoing research on mangroves, this year we will complete a survey of all the Eastern Cape East Coast estuaries, and that will be the third. We've gone every decade and we've monitored distribution and population structure. And we are testing the hypothesis that increased rainfall as a result of climate change will allow some of the temporary coast estuaries to develop more permanent connections to the sea, thereby supporting mangrove expansion. We're also doing, with postdoc Jackie Raw, some propagal dispersal and recruitment models to predict future movement patterns in response to local coastal hydrology and geomorphology. And we hope to have a globally relevant data set on the long-term dynamics of mangroves in a climate transition zone. Moving on to Saltmarsh, we have a range of different species that occur along an elevation gradient. So the greater the elevation gradient, the tidal inundation, the more species we find. So less than 1.5 meters, we have the intertidal saltmarsh, and greater than that, supertidal saltmarsh, with different species distributed along that elevation gradient. The saltmarsh in South Africa occurs in the temperate systems, along the cool temperate and warm temperate coast. As we get up to the subtropical zone, this habitat is of course replaced by mangroves, and enclosed estuaries, because of the higher rainfall and fresher conditions, it's replaced by reeds and sedges. This picture shows that in an area where there's not much intertidal space, we can still find a very high biodiversity with about 5 different zones along the elevation zone going up into the terrestrial vegetation. The number of saltmarsh species increases along this zone. Saltmarsh occurs predominantly in open estuaries where there is an intertidal gradient. However, we do find saltmarsh in some of our other estuary types. And our data has shown that we've lost more supertidal saltmarsh than intertidal saltmarsh, and this is due to activities such as agriculture, development. We have one example of where there's actually been an increase in saltmarsh over time, and that was in a South African national park at Langebaan Lagoon, where they reclaimed some agricultural area and the saltmarsh grew back. The grazing pressure was removed. So there are opportunities for restoration of saltmarsh. When we look at the main threats or pressures, there's been a loss due to development, agriculture, climate change is becoming an increasing threat, and eutrophication, increasing nutrient inputs. We've done a number of studies understanding these pressures and the responses of specific saltmarsh species. And we have a very good understanding of the salinity tolerance range and inundation tolerance range of different species. And we can use this knowledge to predict responses to future climate change, to responses to freshwater inflow reduction. We've also done a lot of work on temporary closed systems because we see that with reduced freshwater inflow due to climate change, the mouth of these estuaries will close for longer periods of time, resulting in high water levels, flooding and dieback of saltmarsh. We have indications of an extension of drought, salinization and desiccation in some of our saltmarsh areas. We're doing long-term monitoring to pick up these changes in salt marshes. For example, we're looking at the effects of sea level rise by using RSETs at a number of locations around the coast. And our research has shown that salt marshes seem to be keeping pace with sea level rise. In some sites, for example in the Knysna estuary shown here, there is erosion of habitats, but in others there is sediment accumulation or accretion. We're also looking at coastal squeeze. So with sea level rise, where will these habitats move? And we've done some modelling using the SLAM model to show this, for example, in the Knysna estuary. But what is slowing down our overall progress on this research question is having accurate digital elevation models for all of our coastal environments. When we look at our policy, it's very limited, and the planning mechanisms are not in place to set aside buffers for landward migration under sea level rise. So this is where we need to do research to inform policy, to influence action. We've started some recent research on sea storms and shown how this is linked to erosion of saltmarsh. With a 10% increase in wind speed, there will be a 26% increase in wave height, resulting in an 80% increase in wave power. And at this particular estuary, we were able to show that erosion of the saltmarsh is related to gale force wind days. Eutrophication. In a lot of our systems, wastewater treatment works are not functioning efficiently. There's spills, there's lack of maintenance, and we have raw sewage frequently entering some of our systems. This causes eutrophication, algal blooms. These can form on top of saltmarsh areas and result in dieback. So we're linking all of this information. We are trying to understand abiotic changes, ecological processes and attributes, and related to ecosystem services. I will now go on to show where we've linked our science policy and management, speaking specifically to the National Water Act and the Integrated Coastal Management Act, the Biodiversity Act, and the National Forests Act. We have estuary management protocol, and I wrote this together with some of my colleagues, that sets out the vision for the management of estuaries in South Africa. And that is that the estuaries are managed in a sustainable way that benefits the current and future generations. And for each estuary in their country, there needs to be an estuary management plan, which is part of implementing the Integrated Coastal Management Act. As part of that, there is a mouth management plan. It is illegal in our country to open an estuary mouth. But as everybody knows, the farmers or local residents, they'll go out at night with their spades and do just that. So to try and legalize that, there's now mouth management plans. We've also provided input to the National Biodiversity Assessment, which has delineated all estuaries in South Africa. It assesses the pressures, status, trends, responses and benefits at the ecosystem type level, and it provides input to conservation and biodiversity protection plans. Ongoing studies are looking at critical biodiversity areas in planning and decision making, and we're trying to use this as another mechanism for protecting our sensitive saltmarsh and mangrove habitats. Looking forward, we're trying to quantify what is happening with pressures. If we look at development as a pressure, there was major development in our country between the 1950s and 1970s, where a lot of ports or harbours were constructed. But we actually find that as a pressure and an impact declining over time now. However, freshwater abstraction and changes in freshwater inflow to estuaries is increasing. We have an increase in population growth, which is an increase in pressure in terms of water quality on our estuaries. Artificial breaching of estuary mouths is another pressure, but this has stayed fairly constant over time. Our estuaries, in terms of our National Water Act, they're defined as a resource. They have a requirement for fresh water, and this is known as the ecological reserve. And since 1999, we have developed methods to identify and assess what this ecological reserve is. We've now consistently applied the same method to more than half of South Africa's estuaries, and so we're the global leaders on understanding the environmental flow requirements and implementation of this in estuaries. Our current research is aligned with the UN Decade of Ocean Science, as well as the UN Decade of Ecosystem Restoration. We're looking at the restoration of saltmarsh and mangrove habitats for the delivery of multiple ecosystem services. We have only a few examples of restoration in the country. For example, here at the Orange River mouth, it forms the border between South Africa and Namibia. It's in an arid area, and so one of the challenges to restoration is establishing hydrological connectivity and the correct amount of flow into the saltmarsh habitats. Here we worked with the Working for Wetlands program of the Department of Environmental Affairs to remove parts of a causeway to allow for tidal exchange into a very desertified salinized saltmarsh area. This led to rapid revegetation of the area by brackish species. In another estuary, the Great Bruck, working with South African National Biodiversity Institute and the Department of Water Affairs, we successfully removed an alien invasive grass. This is Spartina alterniflora, known worldwide. It rapidly takes over saltmarsh habitats, and in this particular estuary, it removed about 8 different saltmarsh species. However, as soon as it was removed, the natural saltmarsh quickly replaced that area. A current restoration project we're working on is desertified, salinized salt pan area at the Swakop's estuary. These salt pans have been abandoned. It was no longer financially viable to continue operations there, and we're looking at taking stormwater from the Motherwell Canal into this area. We are, however, fighting with the environmental legislation to make that happen at the moment. So it's a grand plan. Watch the space for future results. So moving forward, the type of research we are addressing is restoration of saltmarsh and mangrove habitats in line with the UN Decade for Ecosystem Restoration. We're looking at climate change mitigation and adaptation opportunities for blue carbon ecosystems in South Africa. We're looking at the response of blue carbon habitats to climate change, and we're also investigating ecosystem accounting to track change over time. But all of this information has to be integrated, and we're looking at a socio-ecological systems framework to do that, where we can understand estuary state, mangrove health, saltmarsh health, what this means in terms of ecosystem services, and how this translates into the state of the societal system, which includes human well-being, human benefits and values. And so our research teams are expanding to include the social scientists, the anthropologists, resource economists and others. So my personal reflections on looking back to move forward, the theme of this conference, is the exciting opportunities research has provided in terms of evidence-based integrated coastal management. In South Africa, we've had lots of opportunities. We're a small research community and a fairly small governance community. So there's a rapid integration of science in policy, which makes the work very rewarding. More and more, and even lockdown has done this, as ecologists, we get out into the field less frequently than we would have liked to have. In South Africa, we have other challenges such as personal safety. It's just no longer safe to go into certain areas. And so our activities are sometimes constrained. However, moving forward, a lot of research training and capacity building has been done, and we've got long-term observations and the right personnel to continue this data collection. So moving forward, our future of our estuaries and our mangroves and saltmarsh habitats are in good hands. I would like to acknowledge and thank the conference organisers, particularly Dr. Emma Asbridge and for all the communication, Southern Cross University. I would like to thank one of my Australian colleagues, Professor Kerry Lee Rogers, who's taken me to see the range limits of mangroves on both the west and east coast of Australia. These have provided experiences that now allow for global comparisons. Please follow us on these social media sites. Thank you.